This is a continuation of a block 2 thermal physics. Last week we discussed specific heat capacity and specific latent heat. Now most part what we will take is about theories. Very few of them have calculation. So in this topic you will learn about the thermal expansion of solid, liquid and gas. First, a kinetic model of a matter. What is a matter? Anything which has mass and it occupies space, or it is having a volume. What we call that? We call that substance as a matter. And we have three states of the matter: solid, liquid and gas. So we'll discuss. In solid, you can see the particles are tightly packed together. In molecule, in liquid state, the particles can move around each other, and in gases, the particles are far away from each other, so they can move randomly, and very weak force is there between the particles. So first thing you will learn about the properties, about the states of the matter. So we have three states of the matter: solid, liquid and gas. And what are the properties? For solid, in a solid the particles are tightly packed together. They are arranged in a regular pattern. Molecules can vibrate, but they cannot change the position. And the strong attraction is there between the molecule, and they have fixed shape and fixed volume. And solids, it cannot be compressed because already you can see the particles are tightly packed together, so there is not enough space to compress the solid. So these are the properties of the solid which you have to learn. Is it clear? These properties of a solid: their particles are close, tightly packed together. There's a regular arrangement. This regular arrangement is called a lattice. Molecules can vibrate, but they cannot change position. Means this, if this is molecule A and this one is molecule B, so molecule A can vibrate, but it cannot move from one place to another. Is it clear? The properties of solid, and the force of attraction between the molecules is very strong in solid.
Clear.
Then the second state of the matter, which is a liquid state. In liquid, the particles are closer, but compared to solid, are little far. Means there's a gap between the particles, small gap is there. And the attraction between the molecule is weaker as compared to that of solid. Molecules can freely move around from one place to another. And liquid does not have any fixed shape, but it has a fixed volume. And is still, that's in not sufficient space to compress, so that's why liquid are also difficult to compress. So you can see here the particles have spaces but not too much space, so it's difficult to compress. These particles can move around each other, means particle A can move from one place to another. There is no regular arrangement. You don't have a specific or a regular arrangement of the particle. So they take the shape of the container, but it will have a fixed volume. So volume is fixed, but the shape depending on the container in which we are having a liquid. So these are the properties of liquid. Then the third state is gases. For a gas, the particles are far apart. The attraction between the particle is very weak as compared to solid or liquid. The particles are moving randomly. When we use the term randomly, what's the meaning of randomly? It means there's no specific direction. That particle can move anywhere, any direction. That's called a random movement, not a specific direction. They don't have a fixed shape or they don't have a volume as well. No fixed shape and volume. Basically, it's a complete sentence. Gas has no fixed shape and no fixed volume. And we can compress the gases because enough space available so that we can bring these molecules closer. So gases are compressible, easy to compress. Then what are the changes in the state? In solid, you have a regular arrangement of the particle. In liquid, the particle no regular arrangement. They can move around each other, and in gases, the particles are free to move. So if we convert solid into liquid, we call melting. If we convert liquid into gas, we call that as a boiling, or it can be evaporation. If we convert gas into liquid, we call condensation. If we convert liquid into solid, we call freezing. And if solid is converting into gas or a gas is converting into solid, both cases, these are specific terms used, but both cases you can use the term sublimation. So solid change to gas or a gas change to solid, both cases you can refer that sublimation. Is it clear? The process, you have to learn the name of these process when solid change to liquid or a liquid change to gas. Any doubt in this part? No, these are the specific term like deposition, solidifying, melt, vaporize. But the name of the process, both cases you call that as. So if solid is converting into liquid gas or a gas is converting into solid, both cases you can name this process as sublimation. Now, what is the effect of temperature on motion of the molecule? Like if we supply heat energy, if we have a solid, we have a liquid, and we have gas. In solid, the particles are tightly packed together. In liquid, small gaps are there between the molecule. And in gases, the molecules are far away from each other. If I supply equal amount of energy to each, I'm applying equal amount of energy. For example, I supplied 100 joules to solid, I supplied 100 joules to liquid, and I supplied 100 joules to gas. So when we supply heat energy, what will happen to the energy which we supply? So the energy which we supply absorbed by the molecule so when these molecules will absorb the energy, what they will do? The molecules or the particles will move at higher speed and move away from each other. So the substance expand. So what happened when we supply the energy? Example, we supply the energy to solid, a sample of a solid, 100 joule. We supply energy to a sample of a liquid, same 100 joule. And we supply energy to a sample of a gas, same 100 joules. So what happened when we supply this energy? So what these particles will do, they will move faster. And as these particles will move faster, they will move away from each other. So as the particle move away from each other, what will happen to the volume if the particles are moving away from each other? So if we supply heat energy and the particles are moving away from each other, what will happen to the volume of the substance? It will increase or decrease? So the volume will increase. An increase in volume, when the substance volume increase, what we call that as expansion. So the expansion occur. Which one you think expands the most? Like I supply equal amount of energy to solid, liquid and gas. Which one expands the most? Gases expands the most because, so expansion of the gas is more than solid and liquid because particles have weak force between them. So they can move further away from each other. So when we have solid, liquid and gas, and when we compare the expansion, so what we will observe, we'll observe gases expand more than, the expansion of a gas is more than liquid and solid because already there's a very weak force between the particle. So small amount of energy, they can overcome this force and move further away from each other. So this is the effect of temperature on the motion of the molecule. When we supply energy, the molecules move faster, their kinetic energy increase, they move away from each other. Those substance will expand. So if the substance is expanding, what happened to density? If a substance expand, what happened to the density of these substances? It will increase or decrease? The density will decrease. Why the density will decrease? As you can see, the formula density is mass over volume. As the volume increases, increase in volume will reduce the density. The mass is not changing. Why the mass is not changing? Because we have, like in the beginning, if we have 4 particles of a solid, it will remain 4 particles throughout. Is it clear, the concept of effect of temperature on the motion of the molecules? So when we supply heat energy, the particles particles gain energy, the kinetic energy increases, so they move away from each other and the substance expand. Mass can change, but what we are considering there is no loss in mass. Like example, if you have a container, you're assuming that there's no evaporation or no conversion into vapor state. So example, this is a liquid and these are the particles of the liquid. So if I have 5 particles of the liquid and originally the liquid is at temperature 20 degrees. This is the original starting temperature and I supplied the heat energy. So when I supply heat energy, what will happen? The particles will vibrate, they move away from each other. but particles will not leave. If our assumption, then in practical, the liquid evaporation can happen, but we are considering that the particles are not changing the state. If the particles are not changing the state, only we observe a rise in temperature or increase in temperature. So when the temperature rise, what we will observe, if original level was at position A, the new level will be at position B. Why? Because as the particle gain energy, they move further away from each other, so expansion occur. So if this was a start of the experiment, this will be the end of the experiment, because these particles changes the position and move away from each other. So there is no change in mass. Why there is no change in mass? Because you can see amount of matter or the number of the particles are not changing. So when we compare the density, if mass is not changing, mass is constant. If a substance expand, its volume increase, so the density will decrease. Yes, evaporation changes the mass. If evaporation occur, the mass of the liquid will change. But here, what is our assumption? When we explain this concept, we assume that there is no change in the state, only the substance temperature is changing. In practical, when you supply heat energy, the volume of a liquid substance will increase, but as what has happened, evaporation, due to evaporation or conversion of a liquid to gas, the substance volume can decrease as well, and its mass will decrease as well. But our assumption here is that there is no change in state, only change in temperature. Is it clear? So when the temperature is increased, the molecule gain kinetic energy, and increase in kinetic energy. So when you supply energy, the molecules will have kinetic energy. So as they will have gain kinetic energy, or kinetic energy will increase, so the particles will move faster and they will move away from each other. As the particles move faster and they move away from each other, what we will observe, we'll observe the separation increase. As the separation increase, what we use the term, expansion, or we'll say a substance expand. And for a gas molecules, because what happened, the gas molecules are in a continuous random motion, means they're changing their direction continuously. So when the gas molecules are in the container, they exert force on the wall of a container, and when they collide, since the force, so for a gas molecule, what happened, there's another thing what we will observe, they expand also. And there is, if you have a container which is filled with gas molecules, and I'm supplying the heat energy. So as I supply the heat energy, the gas molecule will hit the wall much harder. They will collide more often with the wall of the container. So as they will collide more often or hit the wall much harder, so they create a force. When they hit the wall, they will create a force. And when they apply force on a unit area, what we call that as pressure. So gas molecule, when we supply heat energy, they also exert pressure, or they changes the pressure. For solid, liquid and gas, for solid and liquid, we don't observe too much change in pressure. Why we don't observe too much change in pressure? Because if you have a substance in a solid, the particles are tightly packed together. So when we supply heat energy, because the particle can vibrate and they slightly move away from each other because of strong attraction, Very slight movement is there from their original position. So the solid, only what we observe, we'll observe it expand. But in case of liquid, in case of gases, what we observe when we supply the heat energy to a container which is filled with the gas molecules, we observe that there is a change in the pressure. Why there is a change in pressure? Because when I supply the heat energy, the molecule will move faster because they have higher kinetic. As they move faster, they will hit the wall with a greater force. If the force increase and they collide with the unit area, so force divided by area, what they will create? They will create a pressure. And higher force means it will apply more pressure on the walls. Is it clear? Area of the container, like this is the area of the container. It's a 3D. If you have a container, and inside this container you have gas molecule. So when you increase the temperature, when you supply the heat energy, example, in the beginning only one molecule was hitting the wall, but as you increase the temperature, molecule will move faster, greater number of molecule will hit the wall. As a greater number of molecule will hit the wall, it will have greater force on unit area, so means they will apply higher pressure. Then a process of evaporation. What is, how we define evaporation? When a liquid changes to gas at any temperature, we call that as evaporation. So what happened? Example, you have a container which is filled with liquid. These are the particles of the liquid. So the molecules which are at the surface, because they are exposed to surrounding, means these molecules take energy from outside, and these molecules can absorb energy from particles which are at the bottom. So the molecule at the surface can gain energy. Example, this molecule, it can take energy from the surrounding. And what is the meaning of a surrounding here? So the molecule which is there at the surface, because why the specifically the molecule at the surface? Because this molecule is exposed to the surrounding, the atmosphere, and there are other molecules also nearby. So what will happen? This molecule has a greater chance to absorb energy. Other molecules can also absorb energy, but because the molecule which is exposed to the surrounding or at the surface, it has greater tendency to absorb energy because it can take energy from surrounding as well as it can take energy from the neighbors. So when this molecule take energy from surrounding and neighbor, it has sufficient amount of energy, and when it has sufficient amount of energy, this molecule will go out from the liquid. And this process, when the molecule escape from a liquid and turn into a gas, we call this process as evaporation. So evaporation is a change of liquid into gas when molecule at the surface gain energy from the surrounding and escape. Why this molecule cannot escape? What is the reason why this molecule less likely it can escape? Because it is not directly exposed to the surrounding. It has neighbor molecules, but it is not exposed to the surrounding, and surrounding will have energy which a molecule can absorb. So only this happened for a molecule at the surface. So then what happened? This molecule B is there. This molecule can also absorb energy from surrounding as well as the neighbors, and this molecule will also go out. And what we call this process, we call that as evaporation. So evaporation is a conversion of a liquid into gas when molecules at the surface gain energy and escape. But what happened to the neighboring molecules? If surrounding is cold, energy will be there, but small amount of evaporation can happen at all the temperature. Rate of evaporation may vary, like at higher temperature, if surrounding it's a high temperature, then evaporation will be faster. If surrounding is at low temperature, evaporation will be slower. But evaporation can occur at all the temperature, at any temperature. Rate will be different, but it can happen at any temperature. So when the molecule gain energy from the surrounding and escape, so the molecules which are left behind, what will happen? They will have low energy or small amount of energy. Why they will have low energy? Because they are losing their energy to the molecules which are there at the surface. That is why we call evaporation is a cooling process. Why evaporation is a cooling process? Example, you take a container, it is open container which is filled with, example, water. So you have a container which is filled with water. An example, the temperature of this water is 30 degrees. And you left this container for a few days, like example, for 3 days or 4 days. And after 3 days, what you observe, that the container which you left with the water, so the container which you left with water, you will find that amount of water or level of the water decreased. Why the level of the water decreased? Because what happened? The molecules which are there at the surface, they escape. So as the molecule at the surface escape, so the amount of the liquid or the volume will decrease. But what happened to the temperature? It will be more than 30 or less than 30, this temperature. After 3 days, it will be above 30 or below 30. So temperature of a water which is left after 3 days, it will be below 30. Why it will be below 30? Maybe it can be any number. Example, I'm saying it is 25. So why the temperature is low? Because what happened? These molecules which are at the surface, they are continuously taking energy from the neighbors and going out. So when they take energy from the neighbors, so the molecules which are left behind will have low energy. So when the liquid below its boiling point, the particle gain energy from the surrounding and escape, the molecule which are left behind will have low energy. So you can see here, these are the particles of liquid. These are the particles of a liquid. Arrows are representing they're moving around each other. So the molecules which are there at the surface, you can see the which molecule are likely to go out. So the molecule which are having high energy. So the molecule which have high energy, more likely they will go out. And the molecule which have low energy, even they go out, they can return back to the liquid. So evaporation occur when the most energetic molecule gain energy from the surrounding and escape. And the molecules which are left behind will always have a low energy. That is why evaporation is also known as a cooling effect. Like it cool down the substance. Evaporation depends on different factors. First one, temperature of a liquid. Example, you have two containers. One is at a lower temperature at 20 degrees, another one is 40 degrees. Which one have higher evaporation? At A or B? So B will have higher or greater rate of evaporation. Why B is having a greater rate of evaporation? Because when I say high temperature, it means particles have higher kinetic energy. Particles are moving faster. So if the particles are moving faster, already they have enough energy. That's why greater amount of particles will escape. It also depends on the surface area. Example, you have two containers, but different surface areas. So what happened here at the surface, few molecules are exposed. Few molecules are there at the surface, but large container, greater number of molecules are exposed to the surrounding. Which one you think evaporation will occur at a faster rate? A or B? So B will have a higher or a greater rate of evaporation. Why it is having a greater rate of evaporation? Because the particles, more particles are exposed, so greater number of particles can escape together. Few particles are exposed, so small number of particles can escape together. It also depends on the draught or the wind speed. Example, if you have a still air and you have a windy weather, which one you think evaporation will occur at a faster rate, A or B? Which one you think evaporation will occur at a faster rate, A or B? Evaporation will be faster for B. Why evaporation is faster for B? Because what happened, if these are the molecules, the particles of a liquid, so when evaporation occurs, these particles will go out from the liquid surface. So now this will be the new position of the particles. Same, this is a new position of the particles. But what happens if you have windy conditions? Because the wind, moving air will take away these molecules. So when the wind will take away this molecule, so other molecules have space and they can come out. But when you have a still air, these molecules will remain at this position. So the other molecule don't find space to come out. So if it's a still weather, the evaporation will be slower. When it is windy, the evaporation will be faster. Is it clear? The factor which is affecting the evaporation. So drought over the surface or a wind speed affects the evaporation. Now, what is the cooling effect of evaporation? This you have also experienced. For example, why you feel cold when wind blow over a swimming pool? What's the reason for that? So what happened, example, if this is a swimming pool which is filled with water, and these are the molecules. So these are the molecules of liquid. So why you feel cold when wind blow over a swimming pool? So that's the same reason, because what happened? The molecule evaporation occur at all the temperatures. So the molecules of the liquid escape. As a molecule of the liquid escape, if there is a wind or a moving air, it will take away these molecules so that the other molecules have space to come out. So it will increase the rate of evaporation. So as it increases the rate of evaporation, energy is removed from your body, and that's why you will feel colder. Same thing, you can also experience this cooling effect of evaporation by using a perfume. So example, if this is your skin and you're using a perfume, reason for giving example of a perfume, because it is a volatile liquid, it contain alcohol which can easily vaporize. So this is example, a droplet or a drop of a perfume. What happened? Why you feel a cooling effect because of this perfume? So these are the molecules of the perfume. So what happened? These molecules gain energy. From where they will gain energy? They will gain energy from the skin surrounding as well, and they will gain energy from the skin. As these molecules gain energy from the skin, these molecules will go out, and as these molecules leave, what will happen? This part of a skin, you will feel cold. Why you will feel cold? Because the temperature of this specific part will decrease. So volatile liquids which can evaporate faster, you can feel this effect easily. You can also feel with water as well, but with water the evaporation rate is relatively slower. So with a perfume, with an instant you can feel the cooling effect. Is it clear, this example? If you have, this is a skin, what happened? The molecules in the liquid, from where they will take energy? They will take energy from the skin. So as they will take energy from the skin, so the temperature of this part will decrease and the molecule will escape. So that's why this part of a skin, because the temperature is lower, that's why you will feel colder. And if wind or air is blowing, that will increase the rate of evaporation because the particles are removed from the surface at a higher rate. Is it clear?